Good evening, Middle 3 students, Science Unit 2. We will complete the electricity. Remember in the last video we talked about the two first rules of electricity. The first rule to find out intensity, this is called kit. If I want to find intensity, it is the amount of charges in columns that pass in a cross-section in 1 second. If I want to define the ampere, which is the unit of intensity, it is the intensity when the quantity of charges is 1 column passing in 1 second. واحد يبقى كله وحيد. طيب, let's remember together the second law, through which we will find out the potential difference. If I want to find out potential difference, it is the work done in joules to transfer 1 column across a conductor. If I want to define the volt we know together that it's the unit of the potential difference. The volt is the potential difference when the work is 1 joule to transfer 1 column. كالعادة واحد يبقى كله وحيد. Now there is another type of potential difference which is called electromotive force. We said that the ordinary potential difference is across the 2 terminals of a conductor. For example, in the circuit, the difference between the potential at one end and the other is called potential difference, and it is measured with a voltmeter, which is connected in parallel to the conductor. Whereas the electromotive force is also a potential difference, but for a battery, for an electric cell. Remember when we talked about an electric cell, we said that it has a positive end and a negative end. And when we connect it to a lamp, the charges come out of one end through the circuit, light the lamp and go back through the other end. The force that makes the electricity come out of one end to the other is also a type of potential difference. But since it is special for the cell or for the battery, we call it electromotive force. So as you will find in your notes, the electromotive force is the potential difference across the 2 terminals or the 2 ends of a battery when no current is flowing. مفيش كهرباء ماشية. زي ما أنا بشتري بطارية كده من السوبر ماركت، بجيب بطارية 3 فولت أو 6 فولت. يعني potential difference between the 2 ends of the battery is 3 volts or 6 volts or whatever. Let's remember together the electric circuit. This is a simple electric circle. A battery, a key, and the key is closed for the electricity to pass through, a meter connected in series to measure electric current intensity, and the unit is ampere. This is the resistance or the lamp or whatever we are using, and a voltmeter is connected to it parallel to measure the potential difference between the 2 terminals, and there is a voltmeter connected parallel to the battery. This will measure EMF. Okay? So this electric circuit will measure everything we need. The last thing we have in the electricity is the resistance. When the electric current is passing through an electric circuit or through a conductor, the wires resist the electricity. They don't want it to pass. It annoys them because it takes their electrons. So the resistance is the opposition that the electric current faces in a conductor. There are 2 types of resistance. Fixed resistance, it has a certain beginning and a certain end. We cannot control the length of it. So this is called a fixed resistance. A variable resistance, and another name for it is rheostat. The rheostat, we will be able to control the length of the wire in order to control the resistance. Remember, if the electricity passes through a long wire, it moves a long way. زي واحد كده مشى سكة طويلة بيتعب. برضو الكهرباء لو مشيت في سلك طويل بتتعب. This means that the long wire means a higher resistance and a lower intensity. لو السلك طويل اللمبة هيبقى الضوء بتاعها ضعيف علشان الانتنسيتي هتبقى بسيطة. نفهمها ازاي؟ لو الكهرباء مشيت كتير الكهرباء تتعب ما تعرفش تنور اللمبة. Which means that the intensity and the resistance are inversely proportional. They are opposite to each other. يبقى the resistance are two types, fixed and variable. The last thing is Ohm's law. A scientist called Ohm wanted to find the relation between the intensity, the potential difference, and the resistance. We already know that there is a relation between the intensity and the potential difference. He made an electric circuit just as the one we used before, with an ammeter connected series, a voltmeter to measure intensity, of course, a voltmeter connected parallel to measure potential difference, and a rheostat. This is what we call a rheostat or a variable resistance. As normal or as usual, a battery and a key. Why did he use a variable resistance? He is going to do steps. At first, he is going to put the indicator of the rheostat right at the beginning, so the electricity is moving and it does not move through all the wire of the rheostat, which means that the resistance is very low. And he will measure both the intensity and the potential difference. And then he will keep on changing the indicator of the rheostat to make the electricity move in a longer wire, gradually, bit by bit, until at the end, the electricity will have to move through all the wire of the rheostat. And every time he is going to measure the intensity and the potential difference, he will find that when the intensity is low, the potential difference is low. When the intensity is high, the potential difference is high. So this means that the potential difference is directly proportional to the intensity. Remember, directly proportional relationship يعني آكل أتخن ده يزيد. If the potential difference is higher, the intensity is higher. They are directly proportional. Working it as an equation, this will mean that potential difference is directly proportional to intensity. Potential difference equals a constant times the intensity. If we move this mark, which means directly proportional, instead of it we put equals and a constant. A constant, for example, the pi that we use in the circle, in the math. But here you will not know the value of the constant. You don't need to know it anyway. So V equals constant times I. The only thing that is fixed all through this circuit, all through the experiment of Ohm's law, is this, is the fixed resistance. The A will change, the V will change, and the rheostat will change. This is the only fixed value. So instead of saying V equals constant times I, we will say that V equals R times I. And this will end up in the third triangle, which is called VRI. Here it is. V is the potential difference and its unit is volt. R is the resistance and the unit is ohm, after the scientist who discovered this. And I is the intensity and the unit is ampere. We can find out the intensity from this triangle. This is called the triangle of Ohm's law. We can find out the intensity through this triangle or through this triangle. Which one should we use? We will use according to required, according to the given in the problem. So if he has given you in the problem the potential difference and the resistance, you will use the triangle of Ohm's law. If you are given the quantity of charges in columns and the time in seconds, you will find the intensity through this triangle. The same for the potential difference, and so on. This is the third triangle, which is called the VRI triangle. We can define the volt and the ampere from triangle of Ohm. The volt, it is the potential difference when the resistance is 1 ohm and the intensity is 1 ohm. واحد يبقى كله وحيد as usual. The ampere, it is the intensity when the resistance is 1 ohm and the potential difference is 1 volt. واحد يبقى كله وحايد. طب if you are asked to define the volt, you are free to use either this triangle or this one. If you are asked to define the ampere, you are free to use this triangle or this triangle, unless you are asked to define the volt or the ampere through Ohm's law, you will have to use this one. Thank you.